money to get a new one, watch out for that.
Yeah, and it's always good to benchmark your components when you get them, because then you know if it's going to be bad in a couple months when the warranty's already run out and you're screwed.
I've had that happen. I've made the mistake of not benchmarking my hardware, and had a limited warranty on it. It crapped out. I pretty much had to bend over and enjoy it in the ass. That's about it.
Yeah, and for Windows you have the most number of benchmarking programs out there. A lot of them are free, some of them do cost money, but for the most part they're free. And the ones that do cost money normally have trials that you can actually use. You won't get all of the options, but it'll still give you a good enough benchmark to be able to tell whether your components are going to be able to do something. So I prefer Windows, but as for if you're accessing the BIOS, it doesn't matter what OS you use.
Well, the BIOS isn't OS dependent either way, so...
Yeah.
Alright, so what else do you want to run through in this one? Want to do some BIOS settings?
Yeah, we'll do some BIOS settings.
Alright, we'll cut frame, we'll set up, and we'll go and show you some of the features you need to look for in a BIOS.
Hello, this is Super Archangel. What I'm going to do right now is going into the BIOS. You hit delete on most computers, sometimes it's F3 or F1. It'll bring you into a screen like this. What we're going to do is we're going to go over where the information is, what you're looking for when you're trying to overclock in the BIOS, what are the actual features and things you need to look out for. First we're going to go through system information, because this will tell you what your CPU is currently running at, the number of CPUs, the system memory you have, and it also gives you your version for your BIOS and the build date for it. This is important because some newer CPUs aren't fully supported on older BIOSes, and also some newer BIOSes will allow you to overclock further. So writing down this information, always good to check on the net afterwards. Next we're going to go into the advanced jumper free settings. It'll either be considered jumper free settings or it'll have OC configuration. This is normally where you go for your overclocking. Right now, as you can see, the AI overclock tuner is set to manual. That means I can adjust on this it happens to just be the front side bus, but I can adjust the front side bus to be able to overclock it. Some boards will have an automatic overclocking feature like this one does, and you'll be able to see how you have standard, which is just your normal, doesn't do anything, overclock 5%, 10%, 20%, and AI NOS. AI NOS is a Windows-based software utility to be able to control your CPU. Now, certain motherboards will actually cover an overclock that's done automatically by the motherboard. Asus does on some of their motherboards. Once again, you have to check your information per product to see whether that's an option. Right here we have the DRAM frequency. It's set to auto. The RAM that I have in there is currently 400 megahertz DDR. We're looking at an older computer right now because it has the basic features that a normal BIOS is going to have in an average computer. As you can see, you can set it manually to these megahertz. Some of them actually have it so you can adjust the megahertz like you can for the CPU frequency here, where you can go plus or minus and increase it in actual single intervals. I always try to go in intervals of 2 because computers like 2 better than just 1. It has to do with the coding base. You can also adjust the frequency that your PCI or your HEP is running at. This is, again, overclocking your North Bridge, which is your video controller. Right, we have here is the CPU core voltage. Now, as you can see, this goes up to 1.7 volts. I would never suggest running a CPU that high unless it's under the manufacturer's specs. There's actually white papers out for each individual processor that'll tell you what its max voltage is, what its max temperature is. They normally call them the thermal and voltage specifications. They can be found on the websites from the actual manufacturer. So you want to make sure that you can go up to that voltage, because going over that voltage is risking frying everything, and to me that's a risk I don't take. Right here we have the DDR reference voltage. This is for my RAM. I can up the voltage to 2.5, 2.65, and up to 2.85. Right here we have the voltage for my actual AGP slot, which will send the voltage through the actual GPU. So if you go to overclock your GPU and it's pulling too much power, you may need to increase this in the BIOS. But once again, increasing voltage beyond the specs of what it is actually able to be handled will fry it. And as I said before, there will be white papers and information on all of this from the actual manufacturers you'll be able to find on their websites. If you can't, I wouldn't buy from that manufacturer. Right here we have AI Booster support. This enables AI Booster. It's another thing like AI NOS, except it's not automatic. It allows you to change the values manually within Windows to be able to change your voltages and your frequencies. Next we're going to go into is CPU configuration. In here it'll have your caches, it'll have the actual front size bus speed that the CPU is running at. It'll normally list what the actual CPU is, like what the build number is. Sometimes it doesn't. That's why there's software programs to be able to look at that. It also has a CPU max limit where you can actually set the max, the actual limit for it so that you can boot older OSs that won't support as fast of a processor. And this is so old it even has hyper-threading control. This is CPU internal thermal control. Depending on the motherboard, depends on whether you have auto or disabled. What that is normally to shut it down so that it doesn't fry your CPU, so you almost always want it on auto. Some of them also have a CPU internal thermal control adjustment where if the temperature sensor is off by a few degrees, which I'm not sure how you would ascertain it's off by a few degrees, but if you for somehow know for a fact it's off by a few degrees, you can actually manually adjust it. Next we're going to go into the chipset settings. Chipset settings are normally your RAM settings and your graphics settings for your Northbridge. The configure DRAM by SPD. SPD is your normal default timings, which is the speed that it takes to go through each cycle of reading and writing to RAM. This is what's written on the actual RAM by the manufacturer that the motherboard picks up and reads and says, okay, let's use this at this speed. By disabling this, you're able to go in and change the timings. Memory acceleration mode, sometimes on certain motherboards they have it so that it'll automatically overclock or downclock the memory to match the CPU at a better frequency that'll work better. Because if you have mismatched CPU and memory speeds, it's not going to work as well as if they're synchronized. It's like having somebody that's saying +3 and you only have +2 to be able to put through for pipes. It doesn't work. It's like trying to send 3 gallons of worth of water through a tube that's only able to handle 2 gallons. It's not going to work as well as if you're using 2 gallons for each tube and you have 2 tubes. Same idea. Then you have the APM configuration. This is for powering on, so you can power on your computer by USB, keyboard, etc. The reason why this is important is if you set it up so you can turn it on via your keyboard, you don't have to jump down and shut off the power button if something doesn't happen the way it's supposed to. Like if you're looking with the side of your case off and the CPU fan isn't started up and you're overclocking the CPU, it's not going to be good to have it running any longer than you need to. So if you're able to just hit a few keyboard buttons to shut it off or turn it on, it can save you a whole hell of a lot of money. And then you have your hardware monitor. Most people don't realize this is actually in the BIOS. It's a very important thing to look at. Most CPUs aren't supposed to run around the average temperature for an Intel. They don't want it to go above, I believe it's 42 Celsius right now. This is an older one. It runs at a higher temperature just because it's older. The other thing that's great about this is it'll give you your CPU fan, your chassis speed fan, and depending on the quality of the motherboard, you might actually get your RAM speed, all kinds of stuff, which is awesome. Now, it also gives you the voltage, and almost every motherboard that I've ever looked at will give you the voltage readout. This is important because if it's fluctuating more than 0.05 volts or 5/100ths of a volt, your power supply is not going to be stable enough for overclocking. As you can see, my 5-volt rail right now is bouncing all over the place, and if you look, it actually will bounce down to 4.96 volts, which means this won't necessarily handle a very good overclock, but that's only on the 5-volt rail. The voltage core voltage, which is your one for your CPU, if you actually look at that, that is only bouncing around maybe 1 to 2, so it's stable enough to do a mild overclock. You wouldn't be able to do a major overclock on it though. Alright, so in conclusion, those are the basics you want to look at for actually looking at your computer and actually looking into overclocking. As I would like to reiterate, it voids warranties. Check the warranties. And if you can, get accidental warranty on it because you didn't know you were overclocking anything.
Ignorance is bliss.